Everyone, and welcome to The Explainer. Today, we're doing a complete teardown of an absolutely brilliant technical showcase that came out of Kaggle's 5-day AI Agents Intensive Vibe Coding course with Google. The project is called EcoGuardIA. We're going to look really closely at how this platform engineers climate resilience right ahead of the looming 2026-2027 Super El Niño. This is a true deep dive into how cutting-edge data architecture and AI orchestration are being leveraged, not just to track the weather, but to actively build human resilience against it.
So here is our architectural blueprint for today's teardown. First, surviving Super El Niño. Second, the flawless V1 data architecture. Third, Gemini agents and vibe coding. Fourth, the V2 strategic roadmap vision. And finally, the EcoGuardIA risk index.
All right, Section 1, Surviving Super El Niño, the problem and rationale. Let's quickly set the baseline for why this specific engineering effort is absolutely critical right now.
Look, the stakes right now are, frankly, incredibly high. We're facing severe, opposite climate extremes happening at the exact same time. Massive droughts in northern regions completely juxtaposed with extreme flash flooding in the south. The fundamental engineering philosophy for this project is crucial to understand up front. Nature is a sovereign force. Software engineering shouldn't try to fight it. We literally can't. Instead, we have to build the intelligence required to survive it.
So what exact problem is EcoGuardIA actually solving? Well, global monitoring agencies produce a massive volume of cold meteorological data every single day. But it's isolated, it's highly technical, and it's super fragmented. Pure scientific statistics alone don't save lives, right? So EcoGuardIA acts as this translation layer. It takes those cold numbers and turns them into actionable, humanized warnings. It makes the data preventive, empathetic, and highly localized, so everyday citizens and local governments can actually make decisions before disaster strikes.
Moving right along, Section 2, Flawless V1 Data Architecture. Let's look under the hood at the V1 MVP to see exactly how this data foundation was built. To guarantee absolute data integrity right out of the gate, the EcoGuardIA backend queries the OpenMedia Global API directly. Utilizing high-precision geographical coordinates, this basically eliminates any messy intermediaries. This real-time, direct telemetry ingestion is the rock-solid foundation that ends up feeding the entire AI orchestration engine. In this telemetry, it is hyper-focused on 3 core OpenMedia indicators. First up, current and max temperature. That lets the system immediately detect intense heat waves and rapid environmental dryouts. Second is accumulated rain, specifically the rain sum over the past 24 hours. And third, this one is absolutely vital, structural soil moisture, tracked at a depth of 9 to 27 centimeters. Think about it. If deep soil is already saturated, any subsequent rain is just going to sit on top, which triggers an automatic flash flood risk alert.
Now, here's a really cool edge case they hit in early development. The team noticed that instant hourly readings were throwing these false zero rainfall metrics. Why? Because of global time zone desynchronization. So their solution was this really elegant engineering pivot. Just discard those instant hourly readings entirely, and instead, capture consolidated daily parameters. That one simple step completely shielded the application from time zone-induced data vacuums. Pretty smart.
Okay, transitioning up the stack, let's get into Section 3, Gemini agents and vibe coding. This is where the LLM orchestration layer comes in.
At the user experience layer, the application, which was built in Python using Streamlit, manages internationalization statefully right from day one. So when a user switches between the English and Portuguese interfaces, the system doesn't just, lazily translate static text. It dynamically alters the AI agent's internal guidelines to output native, culturally contextualized analysis in that specific language.
And the intelligence driving this is what we're now calling vibe coding. Instead of relying on rigid, traditional if-else logic trees to trigger these alerts, the developers used the modern Google Gemini SDK alongside Google's anti-gravity concepts. By applying strict system instructions, they essentially molded Google's Gemini 2.5 Flash into a factual, empathetic climate risk expert. It reads complex World Meteorological Organization codes and just acts agentically based on its persona, rather than relying on brittle, hard-coded rules.
The end result is a highly structured output that's designed for immediate public utility. The Gemini model is strictly programmed to consistently deliver its analysis in 3 specific sections. First, the current scenario, which is based on that raw telemetry. Second, a risk analysis that's contextualized specifically for the El Niño threat. And third, localized preventive recommendations.
All right, Section 4, the V2 Strategic Roadmap Vision. Look, the V1 MVP totally proved the concept, but this roadmap escalates the project to an entirely different league.
The V2 Enterprise Vision completely overhauls the interface. We're talking a massive shift from a static dashboard to a highly scalable Next.js interactive WebGL globe. Paired with a really robust fast API backend and hosted entirely on Google Cloud Run, this transforms a localized tool into a true global climate observationality platform. It is visually stunning and technically, it's profound.
But the core of V2 isn't just a UI overhaul. It introduces major spatial and temporal upgrades. We move from static regional points to dynamic geocoding, meaning automatic coordinate resolution for basically any city on the globe. And even more impressively, it introduces temporal memory. So instead of just looking at today's static slice of data, the agent evaluates time series trends. For example, it can recognize that deep soil moisture has depleted by 22% over the last 15 days. That's true predictive insight, not just reactionary monitoring.
And that temporal memory unlocks entirely new layers of deep telemetry. The system expands into hydrological flood modeling, severe weather wind tracking, and importantly, deep agricultural diagnostics. By mapping multi-depth soil temperatures down to 18 centimeters and monitoring evapotranspiration, the system can literally anticipate crop hydric stress weeks before the drought visually manifests in the field. That is a real game changer for agriculture.
Now, to process all of this insane new data, V2 introduces a multi-agent swarm framework. This decomposes complex monitoring into cooperating subagents, so you have a dedicated meteorologist agent, a hydrologist, and an agronomist. A supervisor agent then orchestrates this entire swarm, resolves any conflicting analyses among the specialists, and commands a public comms agent to output the final, culturally adjusted master safety brief.
Which brings us to Section 5, the EcoGuardIA Risk Index. Because, with all this incredible back-end complexity, how do you make it instantly understandable for an everyday end user?
Well, that's exactly what the EcoGuardIA Risk Index does. It's an automated, dynamic composite index that takes all those advanced metrics, temperature anomalies, historical vulnerabilities, soil saturation, wind dynamics, and it weights them all together. The output is a simple, instantly shareable community alert score from 0 to 100. It scales smoothly from a low-risk green all the way up to a critical red. It perfectly distills immense, swarm-level complexity into immediate clarity.
As we wrap up here, I really want to circle back to the core philosophical thesis of this InfoChoice project. We don't fight against nature, we build intelligence and resilience to survive it. It really hits the nail on the head, reminding us that the ultimate goal of cutting-edge software engineering isn't just crunching data, it's creating actionable human resilience. Which leaves us with a pretty fascinating question to ponder. As climate shifts continue to accelerate and our environmental data becomes vastly more complex, are these AI-driven multi-agent swarms going to become the definitive software blueprint for global environmental observability? I mean, it certainly looks like it. Anyway, thank you so much for joining me for this explainer. I hope this deep dive into EcoGuardIA sparked your curiosity as much as it did mine. Keep learning and stay curious.